In this video, we're going to be learning the naming system for different types of oxyacids. Now, we can identify an acid as being an oxyacid, firstly because they contain hydrogen within their structure, as every acid does, because an acid is any substance that releases hydrogen as an H+ ion when it is added to water. However, unlike binary acids, the hydrogen is not actually attached to only a single nonmetal. We can see that the hydrogen is actually attached to a polyatomic ion, which again is a group of atoms that together have a charge when they are arranged in a specific way. And the first stage of actually naming each of these two example acids is identifying what the polyatomic ion is, and we can do this by simply highlighting the part of the acid either in the chemical structure or in the chemical formula that does not include the hydrogen. Everything other than the hydrogen is the polyatomic ion. So if we go to our periodic table and look up NO3 and NO2, we can see that each of these polyatomic ions here have a single negative charge. NO3 goes by the name nitrate, whereas NO2 goes by the name nitrite. And those are going to be the starting step in helping us to name what each of these acids based on these polyatomic ions are called. Now, the next thing that we need to do is identify what type of suffix our polyatomic ion ends in. For example, NO3 ends in the suffix ate, or ate, whereas NO2 ends in the suffix ite. Now, when we convert the name of the polyatomic ion into the name of the acid, all that we need to do is remove the suffix. So we're going to start with the top oxyacid here, whose name ends in ate, because this polyatomic ion is nitrate. Now, if we remove the suffix ate, if we remember the suffix that we used for binary acids, ic acid, this is exactly the same suffix that we have here. So this top acid is what we call nitric acid. We will notice that unlike binary acids, which use the prefix hydro to indicate that hydrogen is one of only two elements, because our oxyacids contain 1, 2, 3 different elements here, which is more than 2. They are not binary acids, and therefore we don't use the prefix hydro. Now, if our polyatomic ion ends in the suffix ite or ite, we follow a similar process. So we start with the name of the polyatomic ion, nitrite, NO2, and we remove the suffix, but this time we're going to replace it, instead of with ic acid, we're going to replace it with OUS acid. So this is not pronounced nitric acid, this would be nitrous acid. And because each of these two acids share a different suffix, we can see that the chemical formula is different, and again, that the name of the acid is based on the polyatomic ion that we add a hydrogen to here. Now, normally we would be done the video here because pretty much every oxyacid follows this naming convention as we see. However, because English is an annoyingly irregular language, we need to go over a few slight exceptions, which are oxyacids that contain the atoms sulfur and phosphorus, because even though the rule remains basically the same, the exact spelling changes a little bit depending on whether the central atom of our acid is sulfur or phosphorus. And we can see that all of these example acids below contain either sulfur or phosphorus. Now, when we discern the name of each of these acids here, instead of naming the polyatomic ion, what we can do is name the individual elements. So, if our acid contains sulfur, we can start by using the element sulfur as the root, and likewise, if phosphorus is the central atom of our acid, we can start by using the name of the element phosphorus, because that's going to be how we modify the name of our acid. Next, we remember that if the polyatomic ion ends in ATE, we replace it with the suffix ic acid. However, in the event that our acid contains sulfur, we're not actually going to remove this suffix here at all, and if the polyatomic ion ends in ATE, we're just going to add the ic acid suffix like this. So this acid here would not be pronounced sulfic acid the way that it would if we removed the suffix. We would actually pronounce this sulfuric acid, and this is indeed the correct spelling, even though it doesn't follow the exact rules that we outlined before. Likewise, if our polyatomic ion ends in ITE, which this one does because SO3 with a -2 charge is pronounced sulfite, whereas SO4 with a -2 charge is pronounced sulfate. And if we remember the rule that if the polyatomic ion ends in ITE, we replace it with the suffix us acid or OUS acid, that's exactly what we do here, only we're adding it on to the element named sulfur, so this would be called sulfurous acid. Now, the spelling exception for phosphorus-based acids, what we can do is remove the suffix US from the name phosphorus. So we would be left with phosphor as our root, and once again, the naming rule remains the same. If the polyatomic ion ends in ATE, we replace this suffix with the suffix ic acid. Now, if you look up on your periodic table, this polyatomic ion, P with 4 oxygens here and a -3 charge, is the polyatomic ion phosphate. So we replace the suffix of phosphorus with ic acid, and this acid would be pronounced phosphoric acid rather than phosphic acid if we were to follow the rules. And likewise, if the polyatomic ion ends in ITE, we replace it with the suffix OUS acid. And as we can see, this phosphorus here only has 1, 2, 3 oxygens, and if you look up this polyatomic ion on your periodic table, this polyatomic ion would be pronounced phosphite, meaning that this would be called phosphorus acid, although note the difference in spelling because we're following the suffixing rule here. So even though these spellings have a little bit of irregularity compared to the pattern that we saw with our first 2 examples, the core remains the same. If the polyatomic ion ends in ATE, the suffix of our acid is going to be ic acid, whereas if the suffix of our polyatomic ion ends in ITE, the suffix is going to be OUS acid. And with that, this concludes our 2 video series on the naming system that is used for acids. To make sure that you understand the naming system for acids, you can take a look at the practice problems below and make sure that you can convert name of an acid into a chemical formula and chemical formula of an acid into a name. And in the final video in this series, we're going to take a detailed look at neutralization reactions, which are the critical reactions that occur when an acid and a base react.